This is a video on graphing a derivative function given the graph of an original function. The question states, the graph of f of x is shown below. Sketch the graph of f prime of x. So here's our graph, and I'm going to go from left to right. So this left part we can see is a line segment. And line segments have constant slope, and we can see that it's a negative slope, and it's not very steep. So what that means is I can put my derivative function below the x-axis because we have a negative slope, but not so far because it's not very steep. And I keep going until I get to this point, at which it becomes another line segment. Now we still have a negative slope, but very steep. So in particular, I can take my graph and realize I'm going to have a line segment that's going to be very far below the x-axis, over here. Then I get to this part, and we see on this piece we have a positive slope, and as I move up, as I move and move, we can see that the slope of the tangent line is decreasing. It flattens out over here. So we're going to start out with a very big positive slope, and then have a very small positive slope over here. And what that looks like is starting out far above the x-axis, and we're going to go down until we get to right about here, at which we have a horizontal tangent line. So that means the derivative graph crosses the x-axis at that point. And that's because it has a zero slope at that point. So then I continue on past that. I have a negative slope because we're going downwards now. So that means we're going to be below the x-axis. And it's getting steeper and steeper, which means we're getting more and more below the x-axis. And I can draw that, and that just continues this line down and down and down until we get to the end of the graph. And that is the graph of y equals f prime of x. And I'm done with the problem.